So in the previous video, we talked about differentials and how to calculate them. And at the end of the video, we were talking about where differentials really are used, like what is the whole point of them. So we said that we can kind of approximate the change of f with just the derivative itself. So with this differential. So let me give you a problem to kind of just see what or model what that kind of looks like. So whoops. So let me give you this example. So given the function, and here is the function, f of x comma y is equal to x squared plus xy plus y cubed. Okay, so we have some additional information. X equals 4. Whoops, that looks like a lot like a 9. So x equals 4. We're going to say that delta x is equal to dx, or approximately equal to dx, and this is equal to 0.2. Y is equal to 2. Delta y is equal to dy, which gives me negative 0.4. Negative 0.1. All right, so what do we want to find? So we want to find a couple things. So find first what the change in f is, and also part B, find df. Okay, so let's see what exactly is going on in this function. So we have this function, it's in three-dimensional space, so we kind of don't know what it looks like unless we use some sort of technology to kind of look what this function kind of looks like. So basically, you are at a point in space. So let me just try to draw it at least in 2D, kind of what it looks like. So you have 4 units in the x direction and 2 units in the y direction. So you're right here. All right, and what we're doing is that we're changing x by 0.2 units. So basically, I'm moving x 0.2 units over, and I'm decreasing y by negative 0.1 units. Okay, so when I change my x, if I increase my x by 0.2 units and I decrease my y by negative 0.1 units, how is that going to affect my f? Okay, so the way that we're going to do it, we are going to do it first the old-fashioned way. Let's just calculate what the actual change will be, and then we'll do the derivative and see how that pairs off. Because what we said was that we can kind of approximate the change in f with the differential. And here we have these formulas that are going to help us figure out this problem. So let's start off with the first part. Oops. Okay. So first, let's go ahead and figure out what delta f should be. So let's just write delta f. This is going to be for part A. So let's figure out what that should be. Well, we know what delta f should be. So delta f is going to be equal to, using the formula that we have up here, okay, the first one, is going to be equal to f of x plus delta x, whoops, comma, y plus delta y, minus the original f of x comma y. Okay, so the first thing that you're going to do is you're going to plug in all of the known information that they gave you in the problem to the function. So I'm going to go ahead and plug it in. So I'm going to have f of x in this case is equal to 4 because that's given to us over here, plus delta x equals 0.2, comma y, that's 2, plus delta y, that's negative 0.1, minus f of x in this case is equal to 4, y is equal to 2. So I'm just plugging it in. So here I'm going to have f of 4.2, comma 1.9, minus f of 4, comma 2. Okay, so now what am I going to do with this? Well, we know how to calculate f of 4.2, comma 1.9 because we know what the original function was. This was the original function. So what I'm going to do is that I'm going to plug in 4.2 and 1.9 into the x and the y's. Okay, so I'm going to plug that in. So I'm going to have a big fat mess. Let me go ahead and write this one for the first part, minus, and let me make the other one in blue. This guy is going to be for this guy. Okay, so the first thing I'm going to do is I'm going to plug in 4.2. So I'm going to have 4.2 squared plus 4.2 times 1.9 plus 1.9 cubed. And the way that I'm getting that is that I'm plugging this guy into the original function, which is this person right here. Okay, so now I'm going to plug in 4 and 2 into the function. So that's going to give me 4 squared plus 4 times 2 plus 2 cubed. Okay, so that's what we're going to get. And this should be a minus. Okay, so if you put this in your calculator, what you're going to get is 32.479. Okay, that's what I got earlier. Minus, and if you put this into your calculator, you're going to get 32. So what you're going to get, so the difference between the change, okay, so if I change x and y by a little bit, how is that going to influence it? I'm going to get 0.479. So this basically is how much is the function going to change if I were to move x by 0.2 units and if I were to change my y by negative 0.1 units. So if I change that by a little bit, this is how much my function is going to change. So this is basically like the truth, okay, the true value. Okay, so now that was part A. That was actually the true change. Now let's figure out what part B should be. So part B is just finding the differential. Okay, so now let's figure out what df should be. So we know what df is. df is just the partial derivative with respect to x dx plus the partial derivative with respect to y dy. Okay, so now all we have to do, we know that the function itself, f of x comma y, is equal to x squared plus xy plus y cubed. Okay, so the partial derivative with respect to x, so partial derivative with respect to x is just going to be 2x plus y, okay, and the partial derivative with respect to y is just going to be, so this is going to go away, so I'm just left with an x, and then a plus a 3y squared, okay? So now let's plug everything into the differential. So we're going to plug everything in here and in here. So df is equal to, f sub x is equal to 2x plus y, and then dx, plus f sub y is going to be x plus 3y squared dy. Okay, so now all we got to do is now plug everything in there. So we're going to try to figure this out. So let's go back to the problem. We know what x and y should be. That was given to us in the problem. X was just 4, y was just 2. Delta x and dx are both going to be the same thing, 0.2 and negative 0.1. Okay, so let's plug that in. So I'm going to have 2 times 4 plus 2. Okay, and then chain dx is going to be equal to 0.2 plus 4 plus 3, 2 squared, and then multiply this by negative 0.1. Okay, so if I put all of this into my calculator, what I'm going to get is 0.4. Okay, so this is actually the approximation. So that's what I'm approximating. So if you look at both answers, here is the truth and here is approximation, you're not that far off, okay? So just by a little bit, we're off by a bit, but you can see that in terms of the calculation, this guy took a little bit more calculation than just the derivative. You know, the derivative actually made it a little bit easier to solve. Now, the question here is, what is the whole point of this? Because clearly I didn't need to calculate the derivative. If I have a calculator or some sort of technology, I can just go ahead and just put it in the calculator and just get it. Well, there's a couple of reasons why this might be easier. Well, A is that it's easier with derivatives. Derivatives might make things a little bit easier to calculate. And the other one is the linearity of df. So one of the advantages, I'll write it here, is that df is linear. Okay, so what does that mean? Well, if it's linear, that means, let's say I take my delta x and my delta y and I double them. I increase them both by double. Okay, if I increase my changes of x and y, if I change my x and my y, if I double them, what that means, would imply that df will also double. Okay, so that's basically what it means. So if I were to change and make delta x and delta y and to change it by a little bit more, or I double it, well, if I already know what this guy is, and if I were to double dx and dy, that means that this guy is also going to double. Okay, so it's really easy for me to just make really quick calculations that way, as opposed to this guy. Because if I just take regular delta f, and if I were to double the changes here, that doesn't necessarily mean that this is going to double. Okay, so delta f does not work that way. Okay, it is not linear. So the linearity of df actually makes it unique, because then it's really easy to see or try to calculate what the actual differences will be. Whereas with delta f, you won't have that type of situation. Okay, so that's just one of the advantages. This is basically just differentials. And if you have any questions, just let me know.